Here we're given a box that has a height x, it has length y, and width z. The volume is 630 feet. The volume of a box is x times y times z. So we have x, y, z equals 630. We're told the height is 4 feet more than the width, so x equals z plus 4, and the length is 9 feet more than the width, so y equals z plus 9. From that, we're asked to find the dimensions of this box, x, y, and z. We'll start with the given volume equation. X times y times z is 630. Replace x with z plus 4, replace y with z plus 9, you get this equation. Get rid of the parentheses, we're going to multiply. First we FOIL, then we distribute multiplication by z, and we have z cubed plus 13z squared plus 36z minus 630. That's a degree 3 polynomial, which implies there are 3 complex roots. So let's find them. We could start with the rational zero theorem. It says every rational root for this polynomial equation will be of the form p over q, which would be equal to plus or minus the factors of the constant 630 over the factors of the lead coefficient a. Well, that makes a very long list. Yikes, it's way too long to calculate. So let's go to another idea. Let's find the quantity of rational roots using Descartes' rule of signs. First, we'll calculate the possible number of positive real roots and the possible number of negative real roots. For the positive real roots, let's take a look at the function f of z, not f of x here. This is f of z equals z cubed plus 13z squared plus 36z minus 630. Only one sign variation in this f of z. That means there will be 1 minus 0 equals 1 or 1 minus 2 equals negative. No, we don't have negative answers here, only positive. So there is going to be one positive real root. For the number of negative real roots, look at f of negative z. Remember how we do that? We go through f of z and change the sign on all the odd powers of the variable. So you see we have one sign change here, the second here, which implies there are two sign variations in f of negative z. And that implies there will be 2 minus 0 equals 2 or 2 minus 2 equals 0 negative real roots. Either 2 or 0. That's a quantity of negative real roots. Okay, let's take this information and let's make a table. Across the top of the table, we will list the positive real roots, the negative real roots, the imaginary roots, and the total roots. When you add these together, they should give you the total. Now on the first row, we're going to start listing the quantity of positive real roots. You know what? I got this mixed up. The first column should be negative real roots, and the second column should be positive real roots. Then everything fits. So just change the signs on the top of the box. One of these two scenarios will be true when we finish this problem. So let's pause and just describe what's in the box. If you make the adjustment on the top, you'll see that on the first column, negative, and the second column, positive real roots, and the third column, imaginary, we're either going to have 2 negative real roots, 1 positive real root, and no imaginary roots, or we're going to have no negative real roots, 1 positive real root, and 2 imaginary roots. Let's see which one applies. Let's go looking for these roots. This time, let's look for integral bounds. So we're going to synthetically divide by positive whole numbers starting with 1, and we're looking for all non-negative values on the bottom of synthetic division. Let's see if we get all non-negative. Here we get a 1 on the bottom. Then we get a 14 on the bottom. We get 50 on the bottom. It's looking good. Non-negative. Oh, it went negative. This is not. X equals 1 is not an upper bound, and it's certainly not a root, or we would have gotten 0 at the end. Let's take the next number, x equals 2, and synthetically divide. These are the coefficients of the polynomial that we have. All right, so we get a 1, a 15, a 66. Looking good. One more positive number, and we got it, and oh, it's negative. Not a root, not an upper bound. Let's move on. Synthetically divide by the next number, x equals 3. There are our coefficients of our polynomial. We get 1, we get 16. What do we have here? We get 84. Negative. Again, no upper bound, no 0, no root. We're hoping for all non-negative on the bottom or a 0 at the end for a root. Let's synthetically divide by 4 and hope for this to be our upper bound. 117, 104, 4, let's see, negative. Okay, no upper bound again and no 0. Okay, let's try one more. Synthetically divide by x equals 5. There are our coefficients from our polynomial. Our first number that comes down is 1, 18, 126, 0. Oh my gosh. It not only is it a root because we got a 0 at the end, we have x equals 5 is a root, and it's also an upper bound. We're not going to find a root any bigger than this one. That is great news. Let's stop and do something with this synthetic division. We're going to start factoring the polynomial using the synthetic division to find the rest of the roots. Okay, so here at the bottom we have, well, we took our original z cubed plus 13z squared plus 36z minus 630, and at the bottom here we see it factors as z minus that 5 times z squared plus 18z plus 126. Well, you know what? We can set that second factor equal to 0 and solve it to find the remaining two roots. Let's do that. Well, it looks like if we set the x squared plus 18z squared plus 18z plus 126 equal to 0, we're going to need the quadratic formula to get the solutions to that thing. So z equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So this would be negative 18 squared negative 18 plus or minus the square root of 18 squared minus 4 times 1 times 126 over 2 times 1. Turns out that's the square root of a negative number, so it's not real. All right, and we're only looking for real roots. We're not interested in imaginary roots. Here's our conclusion. Z was equal to 5. That was one root. Then we have z, not x. Z is equal to 5 plus 4 because remember we said that, x is the other dimension. It's equal to 5 plus 4, and y, the other dimension, is 5 plus 9. So our solution is z, look back at the picture on the very top. The dimension z, which was the width, that's equal to 5. The dimension x, which was the height, that's equal to 5 plus 4, which is 9. And the dimension y, which was the length, that's equal to 5 plus 9, which is 14.